Today we'll be discussing a truly mixed mode circuit, wherein we are using, let us consider this. This is a split trigger which is having analog as input and digital as the output, which we have already discussed. This is nothing but a non-inverting split trigger with hysteresis. That means output will be always high or low. Okay, so this is the digital output, and then this is the integrator, the averaging circuit, okay, or the analog circuit, where whatever input you give, that is integrated and appears at your output. So this is the D to A converter. So together they form a mixed mode circuit loop having D to A and A to D. That means, actually speaking, you can have analog as input, okay, or analog as input or digital as input, okay, at this point, and form it as digital input and analog output, or analog input and digital output, okay, circuit, which is the sigma delta converter of today. Further, this circuit is one of the most popular ICs as a function generator ICs. It has a square wave of fixed amplitude plus minus Vs at this point, and a triangular wave. The square wave gets converted to a triangular wave. We will presently see of a fixed frequency 1 by 4 RC. How it is going to work, we will see. This output is therefore assumed to be either at plus VSS or minus VSS. Let us take it as plus VSS. Then the current in this is VSS by R, which is going to charge this capacitor this way, and this will be going negative, right, at a rate which is VSS by R into C into T, okay, with a negative slope, okay. And as soon as it reaches a certain point here, where this voltage goes to 0, it's already at plus VSS, so this voltage at this point is nothing but VSS into R1 plus, let's say, V0 into R2 by R1 plus R2. When this becomes equal to 0, state changes. Now therefore, this can happen when this is at plus Vs, when this voltage reaches minus VSS into R1. At that time, this goes to minus VSS, and this slope changes to plus, okay, and that means it goes on increasing, and as soon as it reaches now, okay, plus VSS into R1 by R2, it again changes. This keeps on happening infinitely. That means, basically speaking, we have the output here as minus VSS for the split trigger, and this here it has gone to plus VSS, and this remained like that for some time. So that particular time period, okay, is called T by 2, and this being T by 2. Charging and discharging occur at the same time constant, and therefore the time taken to cover a voltage of twice VSS into R1 by R2, that is the total voltage cover, okay, is within a time T by 2 at a rate VSS by RC. So this particular thing gives us the frequency at the time period as 4 RC, or the frequency as 1 over time period. Okay, 1 over 4 RC. So this becomes a highly stabilized amplitude square wave and triangular wave, and this triangle can be converted by using diode function generator into precise sine wave of required distortion, okay, or you can make it go through a saturating amplifier just to get to about 3 to 4% distortion sine wave. So that is the function generator for it. So it has replaced all function RC oscillator, test oscillator circuits, which were earlier using Wien bridge oscillator, with this kind of chip, which is very cheap, okay, for the laboratory purposes of generating waveforms. Further, it has plenty of use, okay, as a loop, which is mixed mode, in what are called as sigma delta converters, which is one of the most important mixed mode unit which is existing in today's days, right? And it is also usable in developing later on we'll see class D power amplifiers, which are currently used as audio power amplifiers all over, okay, where the active device is always used as a switch, and therefore we can do the continuous modulation of the width in order to sort of amplify power. Okay, that is the most efficient way of doing it. Another particular case of such application is the switched mode power supply, which we are also going to discuss. So this, as a building block, is the sigma delta converter, is used in SMPS and is used in function generators. It is also called, if you convert it into a voltage controlled oscillator, which we will presently do by replacing this integrator with again multiplier integrator combination that we did earlier in self-tuning filter. So if you use this as VC and then replace the integrator of that, using this plot, then frequency F0 becomes VC by, okay, VR to 4 Hz. So if VR is 10, it is VC by 40 Hz. So it becomes a voltage controlled oscillator, or it can be used as FM generator. So the modulating frequency is given here. Immediately it modulates the carrier frequency by this particular thing. If VCQ is the quiescent frequency determining voltage, then FQ is the carrier frequency, which is VCQ by 40 RC, and then the varying sine wave, okay, of omega m is applied over that. The frequency is directly modulated by omega m. This is the modulating frequency. This causes the frequency deviation. This is the carrier, right? So this way you can use for FM generator or FSK generator. This is what is used in modulator part of the modem, right? So modem is nothing but where VC is going high or low, thereby changing the frequency of oscillation to one value corresponding to high, another value corresponding to low. So that is called frequency shift key. So we see that this has one of the most wide range application in present day electronics, and this is something that we must study, okay? And KVCO of this is again delta F naught by delta VC, which is nothing but, okay, F naught. So the function generator circuit that we had just discussed, which can produce a triangular wave, okay, has an important application in what is called pulse width modulation. Just with only one more comparator circuit, we can make sure that actually by giving a little bit of positive regenerative feedback, we can make sure that the output is always at plus Vs or minus Vss. Right? So now let us say a triangular wave input is given to this with peak amplitude Vp, then and the time period equal to t. Then this is the V reference applied to the other end of the comparator. As soon as this voltage at the input goes above V reference, it goes to plus Vss as shown here. And as soon as it goes below this V reference, it goes to minus Vss. So we are able to control the what is called duty cycle. What is the duty cycle? This tau by t is called the duty cycle, based on the value of V reference. Right? Now using the similar triangles here, we can write the height of the smaller triangle, which is Vp minus V reference, divided by height of the larger triangle, is nothing but tau by t by 2. T by 2 is that of the larger triangle, and Vp is its height. This is Vp minus V reference, okay, and tau is its width, okay. So this gives you the fact that tau by t is directly proportional to V reference in the following manner. So if V reference is sinusoidal, then the width is going to change sinusoidally. This is called pulse width modulation. Right? And this is the output corresponding to the switch. This can activate a MOS switch also, so that it can handle the power. And then we can put an inductor and a capacitor as efficient rectifier, filter, so that the output is the average of this. What is the average of this waveform? We can say that it is there as VSS for tau and minus VSS for t minus tau, and the time period is t. Therefore, the average of this is nothing but VSS into 2 tau by t minus 1. And what is 2 tau by t minus 1? This is already established. 2 tau by t, minus 1, corresponding to minus V reference by Vp. So this also becomes a multiplier, but most efficient multiplier, and it doesn't depend upon the device characteristic at all. So this is one of the most accurate multiplier. Because one input is the amplitude and the other input corresponds to the width is V reference. So it multiplies two voltages, and therefore this information is very useful because we get back if this is sinusoid, we get back the sinusoid at the output at high power level very efficiently, and therefore this is used as class D power amplifier stage. And presently you will see that all audio stages make use of the device MOSFET or anything as the switching device, and the information can be at high power level efficiently converted into audio power at the output. It can directly activate the speaker, and that is one application. Another application is where this is nothing but a DC to DC converter. That this DC voltage VSS, which can be unregulated, can be controlled at the output by changing V reference by feedback. That becomes a switched mode power supply, which we are going to discuss later.